DI, cybersecurity range, and integrated team services facility. Today your speaker is Mr. Tim Shai. He's with the DoD cybersecurity range, the Mentech.
Yes, ma'am.
So please join Mr. Shai.
Thank you very much. As Connie just mentioned, my name is Tim Shad. I am a program director at the DoD cybersecurity range for Mentech. So I'm going to talk to you today a little bit about using cyber ranges as an enhanced training solution to work in electronic warfare, signal, and cyber activities. So before I really get into things, I want to take a moment just to define what a cyber range is. These words get used a lot. And so I want you to know what I'm talking about when I say cyber range. And specifically, I'm talking about an environment that delivers networks, systems, and stimulation. So the traffic, the bots, the activity in the network that make it look, smell, and feel just like a real environment. At the DoD cybersecurity range, we provide structured network environments, specifically with respect to DoD Blue, so the DoD backbone, base post camp station, programs of record, that kind of structure, to the required degree of fidelity. And that's our mission. We are always, always, always about getting to a level of fidelity that makes it meaningful for cyber warfighters. So if we got to get all the way down to the bits and bytes, that's where we're going. We've got very good at provisioning these environments rapidly, and they can be remotely and locally accessible. So we're going to talk about those different kinds of things. I just turned the mic off, or the, there we go, okay. So the problem statement. So this is what I was asked to speak to, and there's a whole bunch of stuff in here. The need for an advanced, persistent training environment for cyber signals and EW. I'm going to just unpack a couple of things in here as we look at this. All right, so we're looking for a persistent training environment. We've got to be able to inject EW and signal effects. We need to be able to integrate with other systems, warfighter training systems. We need to be accessible from home station as well as combat training centers. We need to be able to get to that level of fidelity where we're actually replicating tactical combat forensics, looking at individual and collective action together in this kind of an environment, and having sufficient fidelity that you could use this to train commanders and how these systems actually behave and working on those human elements that exist outside the systems. The real problem when we're dealing with signal and EW is the fact that signal and EW is fundamentally physical. As the industry has been moving off into virtualization, into cloud systems, that's been fantastic from the cyber perspective because we get the cost efficiencies and the dynamics of using virtual systems. But that's exactly the opposite of what we're trying to do when we get into signal and EW, that these things are fundamentally physical. So how do you handle that? Well, there are two major approaches. You can do simulation of those effects and being able to replay those things, or you can integrate actual physical systems into these types of environments. Simulation is good because it's easy, it's replayable, you can package that up, and it's relatively cost effective. On the other hand, it's limited because you can only simulate those things that you already knew were going to happen in the first place. When we're getting into the physical environment, actually integrating the physical systems, weapons systems, emission systems, those kinds of things, now we have expanded our scope into the full range of what physics allows. So we can delve into the unknown unknowns when we're really looking at what does the hardware do, what do the systems themselves do. So I'm going to give you, as we walk through this presentation, one example where we've done this through simulation, one example where we've done this through physical integration. So we're looking kind of at an OV1 of the general problem set. Right here on the left, we have the physical domain, right? The full realm of physics, spectrum, and all those other kinds of things that are happening. Propagation effects, how does the weather affect these kinds of activities? On the right side, we've got the cyber domain, the domain of logical systems, data processing, data structures, and all those activities that then have an impact there. In the real world, those things converge through the information systems that blend cyber, information systems, and signals. In the training environment, that's where a cyber range can then come into play. That is a protected environment that replicates the entire stack, the OSI model, 7-layer stack, where we go straight from physical all the way up into application layer activities. So that's what we're going to be talking about here. The DoD cybersecurity range itself headquartered in Stafford, Virginia, just outside of Quantico. These are some facilities that we offer here. In terms of being able to deal with the physical world, we have what we call the ITSFAC, the Integrated Team Services Facility. It's 45,000 square feet of integration space. It's a converted beer cannery. And it is fully physically reconfigurable. So you could drive a truck or a weapon system into the bay. It's fully skiffed out, so it can go up to TSSCI. And we have a Faraday cage in there so that we can contain those emissions if we have the need to go there. We've also got satellite links, and we have a mini cell tower so that we can replicate CDMA and cell phone style technologies. The cyber range then itself we've got a full data center, so we can incorporate hardware in the loop. So if we're dealing with tactical radios and those kinds of things, we can connect those things into the environment. And we are fully aligned to the decree range of ranges architecture. So we partner with all of the other major ranges in the DoD. So we're the DoD Cybersecurity Range. There's the National Cyber Range down in Orlando. There is the Joint I/O Range, which is a transport mechanism among all the ranges, and C4AD, which produces command and control systems. We also partner with the other content providers, so the Fort Gordon Battle Lab, for example, and the other service ranges, other content providers. All of that is remotely accessible. We can integrate those things into a coherent world in which to operate these kinds of things. The DoD Cybersecurity Range is remotely accessible through VPN technologies, through web technologies, through VDI technologies, and on the classified side, we use the Joint I/O Range to integrate those systems. We've learned, one of the important things about the range is that they need to be self-contained. They need to be closed. The kinds of things that you're doing in a cyber environment are fundamentally dangerous, and you don't want to have that happen in any kind of real environment. So we keep them closed. It's a DISA STIG Zone C style environment where we keep those closed. But we've also developed a mechanism from a training platform where we can project these kinds of things in a Zone B style environment, which is available from the dirty internet, so that you can go from the internet and be injected into a range style environment while we keep the systems themselves contained. So the DoD Cybersecurity Range, what we offer, one of the major models that we offer here is we have the Tier 1 of the DoD backbone, as well as Tier 2 and Tier 3 infrastructures, which are that base, post, camp, and station layout, interactive bases that are fully reconfigurable to meet whatever mission requirement that the customer brings to bear. Then we also integrate with all these other labs. So the Air Force has a nice range down in San Antonio. The Army is working the Fort Gordon Battle Lab. The Marines have the Marine Corps Cyber Range, which is also hosted at the DoD CSR facility. And the Navy is working their requirements. Other content providers exist out there, and we integrate with all of those. All right, so I'm going to talk you through the DoD CSR model just to give you a sense of the kinds of things that we have in our approach and how we deal with these things. So first, we were tasked to build out the DoD backbone, which is an MPLS cloud in the real world, they're multi-million-dollar routers. We don't have the same number of them. We don't spend multi-millions on those particular routers. What we're looking to do is replicate the behavior of those kinds of things, so they're scaled down to a smaller form factor. Then, hanging off that backbone, we have the interactive bases. So we've fully replicated out DoD structures, including the Tier 2 infrastructure, the security suites. The Army has a different security suite than the Navy, which has a different security suite from the Marine Corps. So we swap those things in as containerized objects. The Marine Corps Cyber Range in this facility here, so we've also built out high-fidelity replicas of the actual Marine Corps Enterprise Network, as well as tactical systems. Then, what you'll notice here on this particular slide, it looks like a little satellite link. We have WAN transport replicators, so we can manipulate the traffic within the environment to make it look like anything we need to. So if we're talking to a ship underway, we can make the traffic look that way with packet loss and jitter, shortened bandwidth, and different kinds of behaviors that we would typically see. So that's a replication capability. We also have that Faraday cage, so we can do actual honest-to-goodness emissions in that environment as we inject that into these systems. We've replicated some enterprise-level services that DISA provides, and we also have a virtual internet and the DISA IAP. So we use those activities and those structures to provide fidelity. It needs to look, smell, and feel just like the real world. And then the interconnection mechanisms here. We have a number of different interconnection mechanisms so that the different range providers, other content providers can inject that content into our environment. Okay, so let me talk you through some of the examples. This is where we wanted to get to. This is a simulation activity that we did. The mission was to focus on battle commanders and their decision-making capabilities as they're affected by the actual physical weather conditions with a UAV. So the mission was a low Earth orbit satellite detects an unknown emission near the Bahamas. A virtual DDG-51 destroyer was redirected to that area, launching a virtual Fire Scout UAV. And then we used a simulation package called STK to model out all of the physics involved in these kinds of in this activity, and then that simulation package fed that data and that telemetry into the range environment. The range environment provided all the systems that then processed those things, all right, and then feeding that back, and the battle commanders had to interact with those systems as the physics package said these things were going to happen. So then we injected cloud cover, and you get a bunch of packet loss. How can the commander, successfully redirect that vehicle to identify that particular target? On the live side, we had a particular mission in which we took actual GSM devices, so cell phones, and in this case was more of an offensive operation, was how do you defend cell phones? And so what we did is we put a Pelican case together, we filled it with a bunch of different style cell phone devices. We put a mini cell tower in there. We took all of that, stuck it inside a Faraday cage, and then connected that into the range, where we then postured the attacks so that from the cyber side, the effect was driven out into the signals, where then from the cyber systems, the operator was manipulating the signals, using one cell phone to exploit another cell phone to exploit the next cell phone. And then building from there, how do you then fix that? How do you deal with that if we're actually manipulating the cell phone towers themselves? And so we were able to propagate from device to device and provided a really interesting information package. So if we're talking then about the cyber training and evaluation platform, how do you do a persistent training environment? One of the things that we talked about is accessibility. Accessibility is a major challenge. And so the Marine Corps tasked us to solve that. And so what we wound up doing is we're able to work through the security processes and develop a system in which we're able to put a web interface in front of the range. And so we use the web interface then to then inject users into the range to keep the range activities well contained. And then we can provide a CAC authenticated mechanism where a soldier, sailor, or an airman or a Marine can access a training environment. So we have a full learning management system that we built in front of it, so you can have structured training activities which are then enhanced by lab-style environments built in the range. Those lab environments are replicated on demand and provided individually to those students. So those students can then have hands-on lab-based access to any kind of environment that they want. In fact, we've also incorporated a hardware-in-the-loop capability so that we can provide actual physical systems for the students to interact with through that network environment in the exact same way that they would in the real world. We have a fully forward-facing customer management team that is always available, ready to receive the call. We are supported by our DISA and our U.S. Marine Corps sponsors, and this is how you would wind up using this. So there we go. Okay, so I'm right about on my time hack, so we can stop here and I can answer questions. Yes, sir. So typically how we interact is the individual DoD customers are going to come with their mission set. We provide the environment that allows them to execute their mission. So we have that capability. Sometimes we have been requested to support the countermeasure development, particularly if our own red team is the one that is providing the offensive capability. So where essentially our guys will go and say, hey, this is what I was able to do to you. But if you put, this firewall rule at this location, these detection capabilities at this location, that would have made my life much harder. Or usually it's, keep your systems patched. Those are oftentimes those kinds of answers. Yes, sir. That's right.
And the ability to dynamically adapt and respond to those with our cyber mission and other aspects. Now, are they leveraging you? Are they really saying, oh, hey, you know what, we're doing that WannaCry tomorrow? Speak a little bit about how the services are actually trying to reach them and leverage your capability in that almost real-time environment. Do you actually stand up and help?
Yes, actually, that's a great question. Thank you very much. Yes, the services and various customers are coming in for exactly that purpose. If we can roll any kind of network environment that we want, with any kind of patch level, any kind of system configuration that we care about, that's exactly the kind of environment in which you would then be able to replicate the behavior of malware, or in a safe environment where we can actually put the real malware in and actually detonate it, and then see how the various systems react to those particular environments. You do that one time in a consolidated space that's designed to rapidly produce these network environments. Then you get a real look at that malware. You get a real perspective on what it's going to do and what you can do to stop it. And so we do have, I don't want to name any names, but we have people coming in to do exactly those kinds of things. We have CPTs doing their daily mission workups in our environment because it is that straightforward to actually build out those structured network environments. They put them in there, define exactly what they want according to the configuration items that we have or the new ones that we build for those bespoke purposes. And then we can then do that and we can actually detonate the malware. And then what we've also learned, one of the proofs of concept that we've delivered is the ability then to record those things, right? If we have that in our environment, we're instrumented up to record it and then produce that as a video. Hey, look, here's WannaCry, here's what it does. We did that with Heartbleed and Shell Shock. For anybody who's involved in any of that kind of thing, I'm a technologist, and I remember reading the documentation for Heartbleed and Shell Shock, and I remember having no idea what it did until I opened up a Linux terminal. Then I was able to actually walk through it, see what they were talking about, and I said, okay, now that makes sense to me. And so that was one of the proofs of concept that we did as well, was to take those things to actually walk through the Heartbleed and the Shell Shock use cases. Here's what it is, here's how it does it, here's how you know you have it, here is the exploitation, here's how you fix it. Everybody go and take care of that, right? So this is an ideal environment for that kind of testing and manipulation of those emergent threats. And that was a driving factor in how we designed this environment, because the world of cyber is simply too fast. It's too fast for standard programmer record acquisition strategies, for instructional strategies, to get those things into doctrinal courseware. That process is too slow. So we needed to provide an environment in which you could dynamically test and engage those things and put out good enough content to address those issues. Yes, sir.
So, Tim, can you just talk about how long does it take to coordinate support? Let's say a customer comes in with a requirement, they want to run a training exercise, so many people. And again, I'm sure it depends on the complexity of the requirement, but kind of just walk through that process.
Yes, thank you. So I'm going to actually break out two separate use cases. There is the structured training, where you've already built the curriculum and you're enabling that with lab environments. And then there's the exercise style training, where there's a particular set of measles that you want your participants to walk through. So on the structured training side, once the curriculum is developed, we can deliver it on demand, so that a student can then engage it according to the authorization rules of engagement for that particular piece of courseware. They can say, hey, connect to environment, and then boom, they're in an environment walking through structured courseware to deal with that. And so then our challenge on that side is simply capacity management and demand management. On the exercise side, that's where we're talking about the custom development of activities. So the standard timeline, I would guess, around there, because as you mentioned, it is extremely variable depending on the complexity of the environment, the sophistication of the customer, and their ability to provide the necessary information. Those things vary very widely, but I would say generally speaking, we deal with a 6-week time hack about where somebody says, hey, in a month and a half, I want to be able to run an event. We want to do these kinds of things, and we can interact with them at about that pace to help them get the information they need to develop those training environments, and then walking through and just validating at the end that what we've built was in fact what they needed. So 6 weeks is a good thumbnail, but very large missions, 1,000-man exercises, those can take 6 months to plan. They can take all year to plan, depending. We have also service same-day requirements. Those 2 guys in a laptop, hey, I just want to come in and do a thing. That's fine. And so we engage through our process to just figure out what it is that you need, and would deliver that as rapidly as we can. Any other questions?
Your range definition, where are you pulling that from like that? -CSR definition?
That's mine. It's the CSRs, which is mine, because there is no, to my knowledge, standard definition of a range, and so it gets used in a number of different ways, right? And so sometimes you're dealing with just a more standard lab environment. Sometimes you're dealing with an environment that is tuned toward tabletop exercises. Lots of different kinds of ways in which the word range gets used. So that's when I'm talking about a cyber range, that's what I'm talking about. I agree with you.
The simulation environment that you have there, Stafford?
So this one, the simulation piece, or the, this one? Yes, okay, that's the. So this is within the cyber range construct itself. So the ITSFAC is a facility that is intended to do for the physical world what the cyber range does in the virtual and the cyber world. So the ITSFAC is, think of a large warehouse. What you're looking at here, this Dod backbone and the Dod CSR, this is the primary asset developed and used by the Dod cybersecurity range. It is a full replica of the Dod world. And that exists primarily in virtual context, although it is hybrid. There are times and places and devices in there that need to be physical in order to get the appropriate level of fidelity. And so we can swap those things in. You notice here on this diagram all these little yellow boxes. Those are the Tier 2 security interconnection suites. At times, the mission requirement is to test those devices for their performance characteristics. And so if you were going to do that as a virtual system, that wouldn't get you the necessary fidelity, right? So we can swap those physical stacks of gear in when that's important. When it's not important, of course, that's when we use the virtual systems, because we're looking to always capture as much cost efficiency as possible, for our customers. That's exactly right. That's exactly right. And so that is the challenge when we're talking about when we're going to EW. That is exactly the issue, right? Sometimes you simply don't know what the answer is because you don't know what the physics is going to do. You don't know how the materials of the systems are going to handle the particular loads and what you've done with those signals. So in that case, that's when it's really, really important not to be cloud-based, not to be virtualized, but instead to use the actual physical systems themselves. When we're talking about weapons systems, from my perspective, cyber geography is not physical geography. These are information systems with very fancy wrappers, right? And this wrapper flies, and that wrapper goes boom, but it doesn't. From an information systems perspective, it doesn't matter, right? So when we're not testing the physical performance characteristics of those weapon systems, but rather we're focusing on the information systems capacity, then we have a much more cost-effective way to approach the testing of those systems. I don't need the full airplane, I just need the emitter on the front, plus the systems that drive it, right?
Your compute and storage capability must be fairly good.
It is.
And you talked about a cyber training and evaluation platform. So does this do online training and storage for people when they come in and want to train on something? You can store their reference or evaluation for their commander to review later or something?
That's exactly right. That is exactly right. So that learning management system is a learning management system, and all those things that you'd expect to find in an LMS, that system provides. And the one little special piece that we've injected in there is its ability to inject the user into the range environment, so that we can use the range to rapidly, dynamically generate those structured network environments that are necessary for a training perspective, so you get that hands-on activity. And then, you know, and from that training perspective, if they walk the course, you know, we've got the records of how they interacted with the course, you know, how they do in the test, how they do in the practical exercise. We can use, and this is an instructional design question at that point, but we can use the real systems, because we're not mocking them up, we can use the real systems to have actual performance-based testing. You know, did you actually do the thing that you needed to do, rather than, as a technologist, one of those things that always annoyed me is that when I was in training and I was assessed by, did you click the right section of the screen at the right time? Because it was a mock-up, right? And I had to go click this or do that. That's not how technologists interact with systems. So when these are real systems, and they have all the performance characteristics of the real-world activity, you can actually test to see if the student did the thing that he needed to do, rather than did you click the right section of the screen at the right time. So we've used that in a number of different capacities to do actual qualification-based testing. So in one particular course that we ran for network assessors, the instructors used our environment to dynamically modify the assessment environment on the students while they were assessing it, so that their different tools produced different results, and then they had to walk their actual TTPs to figure out what really happened here and to deconflict the results. So there's a lot of power in being able to use a range-style environment to enable those training capabilities. Thank you. Oh. So yeah, when you can, you know, we'll hang out here afterward, or you can come meet us at the Connect and Recharge Lounge. All right, well, with that, I think we are out of time. Thank you very much, guys.
That's pretty fun.